Okay, in example 3, we want to find all solutions to the equation cosine of 2x is equal to 1/2 in the interval from 0 to 2 pi. Well, be careful now because this one has a multiple angle, okay? So we're going to have to do a few extra things at the end, but for the beginning part, it's going to start out the same. So we're looking at cosine of cosine of 2x equals 1/2. So I've got the trig function by itself. Excuse me. So we're looking for where cosine is what? Positive or negative? Positive, because it's a positive 1/2. So what quadrants are we in? Good. Okay. So we know our angle this time is 2x. I'm going to go ahead and put that. I'm going to put 2x equals for both of these. Now, is cosine x or y? So I'm looking for where my x is going to be 1/2. So x is 1, which means we're at this angle right there, which is pi over 3. I'll have to move my quadrant 4 down a little bit. Sorry about that. I didn't realize it's so close until I zoomed out. Yeah, quadrant 4. All right. So you said it was pi over 3. Now, because this is a multiple angle, this is the only reason we're going to do this. Even though we're restricted, we're going to go ahead and put plus, and this is cosine, so we're going to put 2 pi in. Because we're going to have to do some work before we can actually restrict it. Only because it's a multiple angle. How do I know it's a multiple angle? 2x, okay? So it could be 2x, 3x, 10x. If it's not just x, if something's being multiplied by the x. All right. And then in quadrant 4, so I know in quadrant 4 my reference angle is at pi over 3. So what angle are we looking at? Yeah, 2 pi minus pi over 3, which is 5 pi over 3. And then our plus 2 pi in. Now, we're going to solve both of these for x. So what do we do to solve both of these for x? Yeah, divide by 2. And we're going to divide everything here by 2. So we do that, we get x equals pi over, dividing by 2 is the same as multiplying by what? So if I multiplied this one by 1/2, that'd give me pi over 6, right? Plus pi in. I'm going to do the same thing to the other side. And so I get x equals, well, it's the same as multiplying by 1/2, so 5 pi over 6 plus pi in. All right, now we're still got to do some work. We're not done. Because of it being multiple angles, there could be more angles between 0 and 2 pi that we weren't able to find just using our quadrants. So in order to do this, I make a table. And so in my table, the first thing I do is my n value. The second thing is going to be that first equation I found. So the x equals pi over 6 plus pi n. And then the second equation, so x equals 5 pi over 6 plus pi n. And so we're going to pick some n values. So let's start with -1. Now I'm going to tell you, most of the time -1 doesn't work, but we're still going to start with it because what if some reason it did, okay? Depending on the quadrant, there is a chance it could. So we're just going to plug in -1 for n. So pi over 6 plus pi times -1, which would give us pi over 6 minus pi, right? Which is what? negative 5 pi over 6. All right, so is negative 5 pi over 6 now between 0 and 2 pi? Because remember, we are restricted. It's not. So that's not going to be an angle I'm going to use. So I'm going to try the next one. So 5 pi over 6 plus pi times negative 1. This is what 5 pi over 6 minus pi, which is negative pi over 6. Is that between 0 and 2 pi? No. All right, so we're going to try another n value. So go up 1 to try 0. Plug it in. And solve. You should get pi over 6. Is that between 0 and 2 pi? Yes. So it's an answer. So I'm going to box it so I don't lose it. Plug in 0 to the second equation for n. We get 5 pi over 6. Is that between 0 and 2 pi? Yes. All right. I'm just going to continue my table over here, okay, because I just don't have room. You have the second slide, but I don't want to lose anything here. So there's my n. This is my pi over 6 plus pi n. And my 5 pi over 6 plus pi n. All right, so let's pick another n value. So let's pick 1. So I'm going to plug it in. So pi over 6 plus pi times 1. So pi over 6 plus pi, which is 7 pi over 6. Is that between 0 and 2 pi? Yes. So it's an answer. Let's plug in 1 to the other one. So 5 pi over 6 plus pi. 11 pi over 6. Is that between 0 and 2 pi? Yeah, because remember 2 pi is 12 pi over 6, right? So this is smaller, so we're still good. We're going to keep going until we get a row that nothing works on, okay? So let's try 2. So pi over 6 plus pi times 2. And I got 13 pi over 6. Is that between 0 and 2 pi? No, because remember 2 pi is 12 pi over 6, so this is too big. So let's go ahead and check. So that means no more n's in that column are going to work, okay? Then let's try the other one. So 5 pi over 6 plus 2 pi, which is 17 pi over 6. Is that between 0 and 2 pi? No, so it didn't work either. So we're done. And the ones that are boxed are going to be my answers. So I'm going to come up here, or you can go below because I gave you that extra slide, and write out what your solutions are. So our solutions were x equals, put them in numerical order. Which one's the smallest one? Pi over 6. And then 5 pi over 6. 7 pi over 6, and 11 pi over 6. And so there are our solutions.